generative coding agents have a critical blind spot. They can build out backend logic with pretty high fidelity, sure, but their front-end output, well, it defaults to a predictable, low-quality aesthetic. So let's get right into how to fix that.
So, look at this. On the left, you've got the standard AI output. You know the look, the generic gradients and really amateur layouts we've all seen. But on the right, that's what's actually possible. A high-fidelity, professional user interface. The difference here isn't a better AI, it's a better process. We can call this systemic flaw a hallucination of competence. Basically, the AI generates a UI that looks like it works on the surface, but it's fundamentally missing the core principles of professional design. And to be clear, this isn't your fault as a user, it's a limitation of the model itself.
And that brings us to the most crucial point. You do not need to go out and hire a design studio. You don't even need to become a design expert yourself. The real solution is to supply your AI agent with superior human-curated design intelligence and to do it in real time.
So in this explainer, we're going to cover 6 free and immediately accessible injection points. Think of these as resources you can use right now to force professional UI architecture directly into your codebase, completely bypassing the AI's built-in aesthetic weaknesses. Okay, our first method is what we'll call component injection. The core idea here is to shift the AI's job entirely. We're moving it away from creation, which is where it fails, to assembly, which is where it really excels.
The protocol for this is incredibly simple. Just 3 steps. First, you visit a verified component library. Second, you copy either a pre-formatted prompt or the raw component code. And third, you paste that directly into your agent and command it to implement. Simple as that.
This really illustrates the necessary shift in your mindset. You have to stop asking the AI to be a designer. Instead, you command it to be an implementer of designs that have already been validated by humans.
The first tool for this vector is 21st.dev. Its specific function is to provide these pre-formatted prompts that are already optimized for large language models. So you're not copying code here, you're copying a precise set of instructions for the AI to follow and execute.
The second tool is UI.io. Now this one offers much more granular control because it lets you extract the raw syntax HTML, CSS, or React for direct insertion into your project. This is what you use when you need exact, precise control over the final output.
All right, let's move on to our second method, blueprint injection. This approach is fundamentally different from the first. Here, we're going to supply the AI with a visual reference, a design blueprint to guide its entire generation process. For this, we use a few different visual blueprint databases. You've got Dribbble, which is perfect for finding inspiration from top-tier designer portfolios. Then there's Landingfolio, which shows you real live landing pages from actual companies, so you can see designs in a real-world context. For more specific needs, navbar.gallery focuses just on navigation systems, and Landbook is another fantastic curated source for high-quality landing pages. Now, the protocol for blueprint injection is distinct. First, find a design you want to emulate. Second, you capture a screenshot of it. Third, you feed this image to a vision-capable AI agent and then instruct it to replicate specific elements, the layout, the color palette, the typography, whatever you need. And what's really useful here is to categorize these sources by their best use case. You should use Dribbble for that high-concept designer inspiration. Use Landingfolio when you need to see how design principles are actually applied in real-world business contexts. And then you turn to navbar.gallery for very specialized components like navigation systems. So, how do these 2 different vectors come together? How do they form a single, cohesive system? Let's synthesize all of this into a unified workflow architecture.
This table really gives you a clear summary. For direct component injection, you're using tools like 21stDev and UI.io to copy and paste executable instructions for direct assembly. For visual blueprint injection, you're using sources like Dribbble and Landingfolio to provide an image-based reference for AI-guided replication.
And this all leads us to one final, fundamental question. What is the core principle that makes this entire workflow so effective?
Here's the bottom line. Your AI is not an artist, it is an engine. And just like any engine, the quality of its output is determined entirely by the quality of the fuel you put into it. Your job is to stop asking it to create its own fuel and start supplying it with high-octane, professionally refined components and blueprints.